Hello, everyone. Sorry I had to be gone today. I'm with the soccer team as they're competing against Big Sky High School over in Missoula, but I will be back tomorrow. To start, let's first go over the answers to the first day for 3.2. So I will leave this up here right now. You can pause the video when I'm done kind of talking. Review your answers, mark how many you missed at the top, and mark each one wrong that you got incorrect so that when I'm back, we can go over any missed questions. We should also have two students presenting their solutions to two of the problems. I believe the questions for day 3 we would be on in reviewing the homework is A5 and C15, and those two students would be Meredith and Angela. So if you would, please go to the front and one of you present each question. And then pause the video now. Take about 2 minutes to review the homework assignment, marking the ones you missed, and then for the two students to write their work on the board up front, go over their work, and then kind of have a mini class discussion regarding any misconceptions that might be existing that we could go over when I return. So pause the video now and come back after that is complete. Okay, hopefully that all went well. We are going to be looking at the second day of 3.2, which is applications of multiplying and dividing decimals. Yesterday we looked at the mathematical techniques, and today we're looking at some application questions, kind of dissecting word problems and then using our new tool to solve application questions. So our starter is this question. Maybe 1 gallon of water weighs 8.34 pounds. How much weight is added to a fire truck when its tank is filled with 750 gallons of water? So pause the video now. Take about a minute to give it a shot yourself, and then we'll come back and talk about it. Okay, welcome back. Yesterday when we were working these, we decided the best way is just multiply the whole numbers and then count how many decimal places we need to go back. If I look at 8 and 34 hundredths, there are 2 decimal places I'm going to need to account for when I am done multiplying the two numbers as if they were whole numbers to start with. So what I'm going to do is I'm just going to multiply 834 times 750 and then move the decimal place back to the left because I know there was 2 decimal places that I was not accounting for when I started. So first thing is multiplying by 0, just moves everything over. So now I'm going to multiply by 5. 5 times 4 gives me 20, and then 5 times 3 is 15, plus an additional 2 is 17. 5 times 8 gives me 40, and then an extra 1 gives me 41. Then we add in 2 zeros here. Now I have 7 times 4 gives me 28. Then 7 times 3 is 21, plus an additional 2 is 23. Now I have 7 times 8 is 56, plus an additional 2 is 58. Line those all up and then add them together. Lining up all the place values correctly, I get 834 times 750 is 625,500. And the last thing I need to do is account for the fact that I was not using 2 decimal places, so this decimal needs to move over 2 to the right. So my final answer is 6,255 pounds is how much would be added to the fire truck. And that's an important thing to account for when accounting for maybe gas mileage of the vehicle when you add that much weight to it. So that's the review question from yesterday. What we're looking at today is some rounding and an application. So question, how would you describe to someone just learning how to round to a specific value? And it's good to put it into words. So if I'm going to round to the hundredths place, what do I do? If I'm going to round to the tens place, what do I do? So what we're doing, what I want you to do is actually pause the video now, take 30 seconds, just describe someone around you. If you had to write a directions book for an elementary student learning rounding, could you write the directions for that? Pause the video now, come back after 30 seconds of discussion, maybe 30 seconds of writing, and we'll go over it. Okay, welcome back. If I were here, I would have written down some people's ideas. What we're going to say is to round to a specific place value, what we do is we look at the value in the place that occurs just after it. And we say if that value is a 5 or higher, we're going to round our current place value up 1. If it's a 4 or lower in that next value, place value to the right, then we're going to keep our place value as it is. So some examples. If I look at 117.6252, I'm going to round it to 3 decimal places. So I underline that third decimal place. That's the decimal place I'm going to round. So I need to look to the decimal place to the right of it. In this case, that would be the 10,000th place. I see there's only 2 10,000s. That's not high enough to round up. So I'm going to round down, which means I'm going to keep that 5 as it is. So it would be 117.625, or 117 and 625 thousandths. The next one is to round to the nearest whole number. Nearest whole number is the same as saying round to the nearest ones place. And so I'm going to underline the ones place. And I look now at the tenths place. Because in the tenths place there's an 8, I'm going to round this number up to 1,463. Next one is just to round to the nearest hundredth. So I underline the hundredth place. So tenths hundredths is 8. I look at the place value to the right of that. See, there's only a 3, so I'm going to keep that 8 as it is. That's called rounding down, and I get 19.48. Last one is to 2 decimal places. That's again the same as saying round to the hundredths place. I see it's a 2. In the thousandths place, there's 6 of those, so I'm able to round that up and say this is 56.83. Those are examples of rounding. And the reason that we round is because in some division problems, the process would continue forever. However, by rounding to a certain place value, we consider this to be good enough. We're getting an estimate for the value, because in all application senses, we're just looking to get an estimate, a number to work with. So we want a number that's good enough. But real places occurs as averages. So suppose that you needed to know the diameter of a steel connecting pin. As a careful and conscientious worker, you would probably measure its diameter several times with a micrometer, and this is something that we'll do here in a couple of chapters. When we do the measurement chapter in chapter 5, we'll look at all the variety of tools that we have available to us to measure things. One of them is a micrometer. You might come up with a sequence of numbers like the following. Because it's such a fine measurement, you might get different measurements, or people might read it differently if it's not a digital micrometer. So you might take multiple measurements and have people then estimate, because how tightly you decide to squeeze it is going to make it get a different reading. So people might get different readings. Maybe one person gets 1.3731, 1.3728, and then we take a multiple measurements, 1, 2, 3, 4, 5, 6. Either we had one person doing 6 different measurements, or maybe 6 different people, each did one measurement, and then we're going to find the average to estimate the actual diameter of the pin. The best answer is to find the average, or another term is the arithmetic mean. You'll never really hear me call it that. That's an old term. I'll usually say the average. Average is just the sum of the measurements, so I'm going to add all the measurements up and divide by how many measurements were taken. So in this case, adding all of the measurements up, I get 8.2418 inches divided by 6 measurements gives me 1.3736333 measurements inches per measurement. Well, that doesn't even make sense really, because the reason that I wouldn't ever record that as an answer is because let's go back and think about what the tool actually did. The tool only measured to the tenths, hundredths, thousandths. It was measuring to the 10,000th place. But if I divide by 6 and I reported this answer right here, all of a sudden I'm saying that the tool can measure at a much higher precision than it normally could. So that's another reason why we round, is because sometimes when you use math, you become artificial in how good of a tool that you have. I'm not all of a sudden saying that this tool can measure to the tenths, hundredths, thousands, 10,000s, 100,000s, or millionths place. I just was using math to get an average. So I'm going to round it to the same decimal place that I had before. So I'm going to round that to the 4th decimal place because I know that the micrometer could only measure to the 4th decimal place. I'm going to report this as 1.3736. The reason that I don't round that 6 up to a 7 is because the place value to the right of it was a 3. So when you calculate the average of a set of numbers, the usual rule is to round the answer to the same number of decimal places as the least precise number in the set. That is the one with the fewest decimal digits. And that's because you don't artificially get better tools just because you use math to take an average. That's why we do that. For your turn, another good thing you should be able to know is find averages for tests. When you're calculating your final semester grade, your tests are averaged altogether to get your test score for the semester. So let's say you score a 91 on a 1 test, a 72, an 84, and a 95 on 4 tests. What would be your average score? Take maybe 2 minutes to pause this video, let everyone give this a chance. Try it on your notebook, on your note packet, and then come back after 2 minutes and everyone's had a chance to try it. Okay, welcome back. We're going to go over it. So the first thing, if I'm going to calculate the average, is to add these numbers up. So I'm going to add up 91, 72, 84, 95. So over here, 91, 72, 84, 95. Showing all my work. We get 1 plus 2 is 3, plus 4 is 7, plus 5 more is 12. Now in the tens place, I have 1 and 9 is 10, plus 7 makes 17, plus 8 is 25, plus 9 more is 342. So I have 342 points in total on my 4 tests. Now I'm going to divide that by 4. So I'm going to say how many times does 4 go into 342. 3 doesn't go in, or 4 doesn't go into 3, but it definitely goes into 34. It goes into 34 8 times, and I get 32. Subtracting off, I get a 2. I'm going to bring down my next 2, so I get 22. 4 goes into 22 5 times. I do 4 times 5 is 20. And then I get 22 minus 20 is 2. Bring down a 0, because this is really 342.0. So I bring down a 0 here. 4 goes into 25 times, and I know this was a decimal point right here, so 4 goes in there 5 times. 4 times 5 is 20. I get a remainder of 0, so my average test score is going to be an 85.5. Here's some applied examples. Let's say you have a certain amount of sheets that are stacked 5 inches high. If each sheet is 149 tenths, 100,000, 10,000ths of an inch, how many sheets are in that stack? I don't want to count those individually, so I'm going to use math in order to help me out. So really this question boils down to 5 divided by 0.0149. So when we set this up, it looks like so. Let's write it here, some more space. At 0.0149, I want to know how many times does that go into 5. And what we do is we move this decimal place over, so we have a whole number here. So 1, 2, 3, 4. I'm going to do the same over here with 5. If I move it over 5, or if I move it over 4, I'm going to add 4 zeros in here. And now I need to ask how many times. It really becomes this question: does 149 go into the number 50,000? So then I say, how many times does 149 go into 500? So it goes in there 3 times. 150 times 3 gives me 450, and I'm 3 less than that, so this is actually going to be 447. I subtract that off. 500 minus 447 is 53. Now I ask how many times does 149 go into 530? If I look at my number up above, I'll get a good estimate, idea of what I should probably be guessing. Again, it's only going to go in there 3 times, so I do 149 times 3 again. I get 447. Subtract that off. I'll end up with 47, if I count upward, is going to be 53, plus an additional is going to be 83 here. So then I bring down another 0, and so it looks like 830. How many times does 149 go into 830? Take an estimate, maybe start at 5 or so. So I'll say maybe 5. 5 times 149 gives me, for sake of time, well, I can know 150 times 5 is 750. Subtracting off 5 more, now I know it's going to be 745. And then I'm left with something here. But the thing is, because this is an application, I'm just trying to get an estimate here. I know there's going to be a whole number of sheets. There's not half number of sheets. So I know it's going to be around 335, around 336, because there's some variation in those sheets. They're not all exactly the same size. So I'd say about 335, 336 sheets should be how many are in that stack. Okay. Your turn, actually, what I want you to do is actually, on this case, use a calculator. So if you want, I have the calculators over on the other side of the wall, at the cabinets. You could grab, or for the next couple minutes, you can have your phone out to use your calculator on your phone. And so here's the situation. Use a calculator, fill in the table for the company, and find the total. So this company has 4 different types of metal parts, and they're sending in an order. The order says how many inches are needed, the number of pounds per inch, the cost per pound, and then I want to know the following. I want to know pounds, W, and cost per part. So number of inches needed, number of pounds per inch is given, cost per pound, pounds, W, and cost per part. So take maybe 3 minutes to fill in this table to find first the number of pounds, and I'm going to do that by probably multiplying these two numbers. So these two, if I multiply, is going to give me pounds, and then cost per part is going to be cost per pound. Well, I know how many pounds I have. I know the cost per pound, so I'm going to take these two and multiply them to get the cost per part. So take, like I said, maybe 3 minutes to fill this table in. I'll come back and we can check it. Okay, welcome back. Let's see how it went. When I fill in the table, I should get the following for the weights, and then the cost for the parts are given below, and you can then find the total by adding up all the other costs. We didn't get any of those correct. Just remind yourself to ask tomorrow. The last one I want to talk about are some arithmetic tricks of the trade. There's a lot of times when you're on the job site that you just need a quick calculation, and these are some awesome tricks of the trade techniques that allow you to divide and multiply by numbers that occur a lot. So the first one is to divide by 5. What's a quick way of dividing by 5? Well, notice that really the number 5 is half of 10. Multiplying by 10 is really easy. So in order to divide by 5, the suggestion is let's first multiply by 2 and then divide by 10. So if I multiply by 2 and then divide by 10, that's the same as dividing by 5. So let's look at this right here. Multiply by 2 divided by 10. So really what they're doing here is 64 times 2/10. And 2/10 is really 64 times 1/5. And multiplying by 1/5 is really the same as dividing by 5. So they're using that reciprocal property. That's why I can multiply by 2 and then divide by 10 to divide by 5. So I'm going to use that trick down here. To do 121 divided by 5, the first thing I'm going to do is multiply by 2 to get the number 242. And then I take 242 and divide it by 10. To divide by 10, I just move the decimal place one to the left. I get 24.2. I can do that all in my head. That probably would have been a hard one to do without a calculator before. Second trick of the trade is how to divide by 25 really easily. To divide a number by 25, first multiply by 4, then divide by 100. So in their case, they're doing 304. To divide it by 25, let's first multiply by 4 and then divide by 100. So what they're really doing is this: 304 times 4 divided by 10. Well, 4 divided by 10 is really the same as multiplying by 2 over 5. And 2 over 5 is the same as, if I'm trying to divide by 25, is the same as multiplying or dividing by 25. So the first thing I want to do is to multiply by 4 and then divide by 100. Because 4 over 100, or 4 over, I'm sorry, I wrote multiply by 4 tenths. I wrote 4 over 100. Let's redo that. Going back, 4 over 100 is really the exact same thing as doing 304 times 1 over 25 is what I meant. And that's the same as 304 divided by 25. That's what they're doing. They're using the reciprocal property. So if I look at 211 to divide by 25, the first thing I'm going to do is multiply by 4. So 211 times 4 is going to give me 844. And then the next step is to take 844 and divide it by 100. Dividing by 100 is moving it 2 decimal places to the left. I get 8.44. That would have been nearly impossible without a calculator before as well. Next trick of the trade is, in order to divide a number by 20, first divide it by 2 and then divide it by 10. Dividing it by 2 cuts it into halves, and if I cut each half into tenths, I'm in 20ths. That's the same as dividing by 20. And so they do it with 86 here. 86 divided by 20, first divided by 2, then divided by 10. Trick 4 is, how do I multiply by 20? Similarly, I'm going to first multiply by 2 and then multiply by 10. You probably use that quite a bit. So I want you to try tricks of the trade 3 and 4 on your own. Take a minute, pause the video, and then come back after you've had a chance to try it. Okay, welcome back. To divide by 20, they said the first thing we're going to do is divide by 2. When I do 424 divided by 2, I get 212. And then I take 212 and divide it by 10. And when I do that, I move it one decimal place left, I get 21.2. Last one, to multiply by 20. First thing I do is to multiply by 2. 53 times 2 is 106. And now I need to multiply by 10. So I take 106 and multiply by 10. Move decimal place 1 to the right now because I'm getting bigger. I get 1,060. Those are some tricks of the trade when you are dividing by 5, dividing by 25, dividing by 20, or multiplying by 20. These first two are really handy. That is it for today. We are on day 4 of the assignment sheet. So we'll be looking over that tomorrow. I'll check both days' homeworks. Be sure you have the first days corrected. And I will see you then. Thank you very much.